Now let's move on to our second session titled Climate Change, Environmental Friendly Principles with Engineering and Technology. Bindu ma'am, are you here?
Am I audible?
Yes, ma'am, you're audible.
Oh, thank you.
So we are privileged to have Dr. Bindu PK, Head of Environmental Engineering at TIAS, as our second speaker for the evening. I now invite Dr. Suraj Rajan C to kindly introduce our distinguished speaker.
Day 2, that is a session, is handling by Dr. Bindu BK, currently the head Environmental Engineering, Tropical Institute of Ecological Science, TICE, and was a professor at the Department of Civil Engineering, Rajiv Gandhi Institute of Technology, RIT Kottayam. She holds a PhD from Cochin University of Science and Technology and MTech in Environmental Engineering from IIT Madras and an MSc in Environmental Studies. With extensive experience in teaching and research, she has published more than 35 papers in international and national journals and conferences. Dr. Bindu has undertaken several funded projects and consultancy works in civil and environmental engineering, and she has held various academic and administrative roles and also the manager of the Center for Continuing Education. She is a life member of ISTA, ICI, and IGBC and is actively involved in environmental consultancy services and community initiatives. With this short bio, I welcome Dr. Bindu BK for the next session.
A warm good evening to one and all. Thank you for the nice introduction by Suraj. Thank you, Suraj. I'm extremely happy. Am I audible?
Yes, ma'am. Audible.
Yes,
Yeah.
ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay. I'm extremely happy to be here on the first day of the ATAL FDP on climate change. And first of all, I congratulate Amal Jyoti College of Engineering and especially the coordinators of the program to select this apt topic, climate change, which is very hot. As the name indicates, it is very hot and most discussed topic nowadays. And also, my congratulations to gather this much people, more than 100 people participants at this late evening hours. They are listening us. I'm happy for that. And I hope that all the participants are across the country from different states, right? From different backgrounds, civil engineering, mechanical engineering.
Yes,
Is
yes,
it like
yes.
that, sir? Yeah, thank you. Before starting the session, let me ask some apology because I have low voice. I have low voice because of after traveling for the last few days, my throat gets infected. Still, I hope that I'm audible to a marginal level. Let me share the screen. Only can you allow me to share the screen? And it is showing that only meeting organizers and presenters can share. Hello, Suraj.
Yeah, yes, ma'am. 1 minute, ma'am. 1 minute.
Okay, okay. Yeah, now it is okay.
Okay, thank you.
Which I have to start, entire screen or window? Can you see my PPT now?
Madam, the whole screen is visible now. Downloads. That folder is visible now, not PPT.
Okay, okay. Let me close that one. Is it okay now?
Yes,
Yes,
ma'am.
ma'am.
Okay,
Yes, ma'am.
okay. If I put it in the slideshow mode, please check whether the slides are moving. Can you see the second slide now?
No, ma'am, it is not changing.
Yeah, then it is better to put it as other mode. Now it is okay. Can you see the slides moving now?
Yeah.
Yes, ma'am. Yes,
Yeah.
ma'am.
Okay, okay. Then it is better to do like this. So again, with the due gratitude and thanks, let me start the session. So I think all of you have uh, listened, all of you had listened a very nice session by Babu sir. And I was also in that towards the last portion of the session. And the sir told a very uh, beautiful quote at the end, when an environmental activist is a person who acts, not preaches or tells something. So with that in my mind, let me start my session. uh, so the climate change, the environmentally friendly principles with the engineering and technology is the topic assigned to me. So let me start the session with a uh, two questions. Session with two questions. So as it is in online mode, I cannot get the response from others. So, but still, can you think a few words which are related to high climate change? Can you think? I'm not asking you to tell. Can you think a few words which are related to climate change? Just imagine. Then the next question is, can you think a few things or words or something like that which are not related to climate change? The second part, I'm sure that many of you uh, thought some uh, have thought some points or things which are not related to climate change as you feel. But I am damn sure that whatever you think, just like a mobile phone or the uh, tea we drank in the evening or the book I read just now. So yeah, if you take anything in the world, you cannot exempt it from the effect of climate change or either cause or the impacts of climate change. So that is the broad uh, field of climate change. So as very similar to any other topic, so climate change or any other topic can be explained in four systematic way. What is that? What are the reasons for that? What are the impacts of that? And what can we do for it? So similar to that, climate change, what is climate change? I know all of you are teachers and you are teaching from the beginning, from your you have been teaching or you have been learned from your teachers and you have been teaching your students every day on this topic. So all these things are not new to you. So, but for a smooth entry into my topic, I need to uh, run through certain slides, like what is climate change and what causes climate change and what are the impacts of climate change. And lastly, the most important one, what can be done to reduce the climate change. Somebody, if my voice is not audible or some disturbance, please tell me during my session. So climate change, you know the difference between weather and climate. Weather is very short-term conditions, while climate determines the long-term characteristics. We have been studying it from the 6th or 7th class, weather, climate, etc. And global climate is connected to earth, sun, oceans, etc. And you are well versed with the term global warming. What is the physico-chemical action in the global warming? What are the causing gases, carbon dioxide, methane, nitrous oxide, etc. And what are the action or reaction in the atmosphere? That is, these gases are transparent to solar radiations, and they trap long wave terrestrial radiations, thus the increase in the temperature of the earth. This is very familiar to you. And also you have been seeing many things in Google, and you are being teaching this to your students, that the gradual rise in temperature from 1860 to 2040, 60, like that. So these are the data, and these are the contributory gases and contributory actions for the climate change. So many actions, that's power generation, goods manufacturing, deforestation, transportation, everything, every human activity can cause global warming. And can we say global warming and climate change same or synonymously? Even though many times we are using it synonymously, it is some little bit difference or difference in the level of what it is called. It's a plain level of its meaning. So global warming is just the rise in temperature, and you can see that heat is energy, and when you add energy into any system, changes occur. Similar to global warming, when it is applied in the whole space, it can lead to climate change. So it is technically different, but the causative factors are same. So effects of climate change are very well versed: hotter temperature, severe storms, drought, etc., melting of glaciers, rising of sea level, flooding, worse drought, supercell storms, increasing tornadoes, etc. And you are thinking of global warming. I am also thinking of global warming. And this classroom and outside the classroom, your society, your home, whole people are thinking of global warming, but what action the whole world has taken, the world leaders have taken, that we should know. And for that, there are certain milestones in the history of climate change. And first one is the Stockholm Conference on Human Environment, United Nations Environment Conference on Human Environment in 1972. Hope all of you are aware about it. That was the first global summit or global convention on human environment. Till then, people were not, or global leaders were not aware, that much aware. I am sure that most of you have not even born at that time, 1972. At that time, the world leaders started thinking of curtailing what is to do with the increasing temperature. So at that time, many world leaders, a lot of world leaders have participated in the meeting. And have you heard of a speech made by a world leader or a national leader at that time? It gets a lot of applause and reputation from all other participants, all other world leaders. Any idea? Can you say can somebody say the name of that leader? Anybody has heard of that? Yes, Vivekananda talks in Chicago. All the world religious leaders appreciated that. Similarly, a world leader talked in this conference, and it was well appreciated by all other leaders. And to give a clue, it is it is an Indian. Can somebody say? That person is from India. Nobody? Or all are muted? And that person is known as the only one man in the parliament. One man in the parliament. Only man in the parliament. I think all are not happy with the late hours. Okay, it is none other than our then Prime Minister, Srimati Indira Gandhi. So she made a wonderful speech on that global climate change and other things, global environmental issues. And 20 years later, this is in Stockholm, and that Stockholm UNEP was formed. And later, after 20 years, Rio de Janeiro Earth Summit has happened, and 79 countries participated in that one. And in that conference, UNFCCC, United Nations Framework Convention on Climate Change happened. And based on that, 97 Kyoto Protocol and 2015 Paris Agreement happened. And then after that, every year, conference of parties have been are meeting every year, discussing the issues. So, hello.
Excuse me. Okay. Continue, ma'am. You can continue.
Okay. So the COP is numbered from 1995, and the latest COP has happened in 2024, COP 29 in Eastern Europe, and the upcoming COP Conference of Parties meeting is in Belém, COP 30. So we should be aware of that one. Anyway, United Nations Summit on Sustainable Development in New York happened in 2015. And from that, at that meeting, a new plan called Transforming Our World, that the 2030 Agenda for Sustainable Development by 2030 has arisen. So then comes the concept of sustainable development. So some 17 sustainable development goals have been framed. You can see that the 17 sustainable development goals have been framed, and with the 169 targets. These are the 17 sustainable development goals. You are familiar with it. And even though it is numbered from 1 to 7, you can see the 13th SDG, that is climate action. Actually, many of the other SDGs are related to, or in some way or other way, it is linked to climate 13th goal. We are moving with that one. On 1st January 2016 or 31st December 2015, both are correct, 17 sustainable development goals have passed by for the 15 years, that is 2030, it should be achieved the goals. And I'm not going to. So goal 13 is the climate action, where to take urgent action to combat climate change and its impacts. That is, it is said that 2010 to 20, that is the last decade. That decade was the warmest decade ever recorded. So highly vulnerable actions, activities have happened during the last decade, like deforestation, forest fires, and flood, and many other things. So the world leaders thought that if it goes like that, if it is unchecked, climate change will cause every global temperature to increase beyond 3 degrees So we have to curtail it at least to the half, 1.5 degree centigrade. And in COP26, that is Glasgow Climatic Conference, and it took a decision that to phase out the fossil fuel vehicles and the coal-fired power stations. What I said are some important milestones in the history of sustainable development and climate change. And then at this moment, we have to think that what we can do, like the world leaders are doing many things, like policies are framed, but actually the actors are, we are only, actors are us. Because as Babu sir said, we are the activists, not the uh, India government or US government or something like that. It is, they are not the actors, but they are the policy makers. We have to act. So what can we do to curtail the or to reduce the climate change? That is the, okay. Many nations have achieved many targets. For example, Bhutan is the world's most carbon negative country, Bhutan. So they have taken that much action to make this credit. And excuse me, Scotland is officially coal free. They are free from coal. And Costa Rica achieved 99% renewable energy this year. This year means last year, 2023. And there are 50,000 wind turbines across USA, but China is the world leader in wind power. Similarly, Germany's bike superhighway could take 50,000 cars. They have replaced 50,000 cars effects by bikes. Nicaragua has pledged 90% renewable by 2020. So like that, many countries are, it is only a few examples, not the full things, but we have to think, can we do more? Can we do more? Not we cannot wait for Indian president or Indian prime minister or other ministers or somebody, Indian leaders to act. We have to start action. So for that one, let me come to my topic connected to this one. Let me, it is not a proposal, it is an existing thing, but I think I know that many of you are very familiar with the green buildings, but if somebody is not much about this one, I just introduce the concept of green building and how the green building rating systems in India. That's my plan in the coming slides. So why green building? A study showed that if you take the greenhouse gases, 40% of the total greenhouse gas emissions comes from buildings, and it is published in a journal called Architecture to 2030. If you add the other infrastructure like transportation, industries, etc., to support the buildings, then it will come around 70%. So if you put some effort in the design and construction and operation of buildings, we can reduce much carbon or greenhouse gases, and the carbon footprint will be reduced. So by building green, we can reduce the impact our building have on contributing climate change, while also building resilience to our homes and communities. So it has two phases. So you have seen this figure. So to define a green building, it can be defined as the one which uses less water, optimizes energy efficiency, conserves natural resources, generates less waste, and provide healthier space for occupants, and compared to conventional building. If you compare with the conventional building, these are the advantages or these are the merits of green building. So they are designed to reduce the overall impact on human health and natural environment. So a central part, if you imagine greenhouse as a central part, it consumes raw materials, at the same time release pollutants. So we have to reduce the consumption of raw materials, energy, water, etc. At the same time, we have to reduce the production of byproducts and waste products, and thus keeping the environment clean. This figure I'll show you at the end of the session once again. The concept of green buildings are from the very site planning, how to make the site planning sustainable, and building design, optimization of the building design, optimization of the energy performance, utilization of renewable energy, waste and water management, solid waste management, sustainable building material management and construction technology, and of course, health and well-being of the people, occupants, and the quality of the environment. So we have to consider all these for a building to be green. So how to make a building green? Again, we are selling, these are the concept, and of course, we all have studied during our course, whether it is in civil engineering or mechanical engineering or electrical engineering, computer engineering, anything, or if it is a science, we should use that. We should use that knowledge. And we are teaching our children or teaching our students something to better the society and better the environment. We should use all the principles and our brain to, or conscientious to make the environment, make the buildings green. Because sustainable site planning with the bioclimatic architectural planning, we can do that for our own house. If you are suppose you are an engineer, suppose you are an owner of a building, or a proponent or a client or a consultant, or in all way you have the role to act to make the building green. So it not only a building, it can be a road, it can be a dam, it can be an infrastructure, any infrastructure. So everybody has some role in that one. Okay, a site planning and bioclimatic architecture, architects and civil engineers have a lot of role in that one. Design energy efficient lighting and HVAC, that is heating, ventilation and air conditioning system. Civil engineers, mechanical engineers, electrical engineers, everybody has part in that. Low energy and renewable materials. Choose construction materials and interior finishes products with the zero or low emission to improve air quality. Like that, we have many spaces to act on. So in this, I think it is not very clear in that one. Sorry. Can you see the slide? Can you read the slide? Maybe difficult. This is the 13th SDG, Sustainable Development Goal, and many other goals are related to it. And Sustainable Development Goals and green building concept both are going in hand, because in 1970 or 72, this concept of climate change started, but in 2001, green building technology, that IGBC, that is Indian Green Building Council, has started its function, and on its way 2004, 6, 7, 8, it comes like that. It is Sustainable Development Goals, climate change, carbon credits, and green building technologies, everything combined together, and these are the milestones. I shall leave this PPT to you. You can read it later. And now we are standing here and we are proceeding, we are advancing with the better and better technologies for the next sessions. And of course, green building certifications are there, should be there, because a building to be green, it has to meet certain criteria, because we have, when an exam results comes, we can get first class or second class or honors or distinction like that. So we have to grade it. So for that, the certification process is necessary. Otherwise, people will not make it seriously. So certified green buildings have lower carbon footprints and improve resource use and indoor air quality. And these certifications promote new technologies. There we have roles. We have promote new technologies and ideas for more eco-friendly and strong buildings. So in India, we are now coming back to India from US, Europe, Australia, we are coming back to India. In India, we have 3 certification technologies, rating systems. Indian Green Building Council, that is IGBC, then GRIHA, then LEED. So we shall see them one by one. Green Building Rating System, it is not from the not during the construction. It has to be start from the beginning, when it is in the thought process till the completion and throughout the life cycle, throughout its life. So it is not you imagine this certification process as an accreditation in your college, right? When accreditation team, we are sure that we have to go for accreditation, we have to think about it, and we are all doing everything fine and going together, and every process should be documented and filed and submit for the process, right? And until we get an accreditation, so 5 years or 3 years or like that. Similarly, here also we get an certification. So these are certain rating systems across the globe, that is BREEAM, GB tool, LEED. Most of you have heard about LEED and IGBC. So if you tell by country, Australia practices Green Star. Excuse me. Brazil plans practices Aqua or LEED Brazil. Canada practices LEED Canada. Can you see the slide once in between? Let me ask. Suraj?
Yes, madam, it is visible.
Okay, thank you. In China, global GB evaluation standard, Finland, like that, it comes like this. And in United States, UAE, it is PEL rating system, and India, it is IGBC, GRIHA, and LEED. United States, it is purely LEED only. And the 3 rating systems in India are IGBC, GRIHA, and LEED. You should know the difference. So IGBC is usually the most commonly used system, and that is for private building, public building, and sometimes government building also. But GRIHA is mainly for public and government buildings, and it is developed by TERI. You know what is TERI? The Energy and Resource Institute, TERI, and Ministry of Renewable Energy, MNRE. And LEED is the Leadership in Energy and Environment Design, that is world rating system, globally accepted. Usually it is used for multinational buildings and commercial buildings. Let me tell something more about the Indian Green Building Council, that is IGBC. Actually, Confederation of Indian Industry. Have you heard of it? CII, Confederation of Indian Industry. It is a non-government, non-profit, industry-led, industry-managed organization. That is an organization led by industry, managed by industry, but non-governmental and not for profit. So that CII works to create and sustain an environment conducive to the development of India, for the apt development of India, partnering industry and civil society through advisory and consultative practices. So IGBC comes under or as a part of CII, formed in the year 2001. The vision of the IGBC is a sustainable built environment for all Indians, sustainable built environment for all Indians, and facilitate India to be one of the global leaders of the sustainable built environment by 2025. That is by next year. And very happy to say that India is now third in position in the globally. So people, many of the people prefer IGBC over Griha. These are the two common systems. Griha is actually purely developed within India and only for residential and some particular type of houses. But IGBC is a part of World Green Building Council. Its branch is Indian Green Building Council, and it is at par with the LEED and any other international goals. And so any consumer or any client, suppose I build a house, or I build an office, or I build an industry. If I have to follow IGBC green building, one reason is that I should be an activist. I should have commitment to the environment. At the same time, I should have some monetary benefit. People will think like that also. So for that, if you are a developer, your properties would have higher market value and it will make appealing to the buyers, investors, and global stakeholders. So that is an added, some motivation should be there to make green building. So that is one part is commitment to the environment, and second part is some benefit for the developers, monetary benefit for the developers. So anyway, IGBC promotes sustainable building practices in India. And this rating system certifies green building based on environmental, economical, and social factors. Earlier, there were only economic and social factors, but nowadays means for the past 30, 40 years, people are thinking of environmental components also. So IGBC has launched about 31 green rating systems. You may be wondered that what are the 31 types of buildings? If you residential, you can have a villa or a flat or it's a living group community or some old age homes. So similar different types of dwelling places are there. No? So this comes the residential. There are 5 types of residential, like green homes, green residentials, green affordable housing, nest, like that. Then different types of commercial, different types of industrial, built environment, net zero project, and other building typologies like IT parks, then what it is called, airports, like that. So bigger projects are there. So that is why there are 31 typologies. 31 typologies IGBC are rating. And the ratings are usually given in 4 levels. One is the minimum mark, that is certified, just like we pass the exam. Then we get the silver, above that silver, that it may be second class, then gold, then platinum. So according to the points obtained through the IGBC certification process, it is rated like platinum, gold, silver, or simply certified. Okay, and the certification level reflects the building performance in areas like energy efficiency, water conservation, and waste management. Then this certification process, just a minute. Excuse me. Then in the certification process, the pre-design, it has to be started from the pre-design till the completion of the process. Pre-design means it is not the design stage, but it is the pre-design. So when the idea is in our brain, we have to start the certification process. Pre-design means in the thought process. So that is the very early engagement in the IGBC to review designs, plans, and ensure compliance with the rating system. Then the actual operation phase, that is the construction and documentation phase. Then the final inspection, and then give the certification. But it should go on. It should go on the life cycle process. These are the rating systems. I think it is added in later course. It will be added. That is, now it is that there are 31 typologies, but soon it will be 32, 33 or so. Now, as per the IGBC rating system, there are 7 category or 7 features of a building are to be evaluated or certified. Okay, and it is not customary to practice all these 7 features for all typologies. Okay, it is a general thing. And for example, for factory building, rating system is sometimes it is different from an airport, or that may be different from a residence. So there are, if there are 31 typologies, 31 codes are available for IGBC. Okay, so sustainable, these are the 7 main categories or features. One is sustainable architecture and design. When I read the title, you can imagine what all are included in that one. Sustainable architecture and design, site selection and planning. Then 3 important things: energy efficiency, water conservation, that is water efficiency, building materials and resources, indoor environmental quality. The last is the most important one, innovation and development. So these are the 7 main features of any green building. So in the if you have any thing to ask me or intervene, you can do it during the session also. There is no issue for that. Sustainable architecture and design in the IGBC process. What I am telling when I tell each step, you please remember or think what is my role in that, if whether I have a space in that one. If you find a space in any of the step, you can contribute and you will be a part of the climate change reducer or the global warming reducer. Okay. So if somebody is very efficient in architecture and a planning for a very eco-friendly architecture, you have a role in this one. Because you may not be, because you already have a house, so you are not going to build another house in your lifetime, but you can contribute in some other way. You can help your neighbor, you can give some advice to your friends, or you can be a consultant, you can be an engineer to them, you can be an advisor to them, like that. So sustainable architecture and design means it has three main parts. One is the integrated design approach. Integrated design approach means for a building, if we build a house, we used to contact uh, masons or electricians, plumbers, uh, and some flooring work people, painters, etc. Similarly, if when you put a design, when you propose a bigger project, you should involve architects, civil engineers, electrical engineers, uh, other planners, economists, then design, structural engineer, etc., into the into the into your plan work, and there should be an integration of the uh, opinions or the designs from all of the people, all of the experts, and different project teams. And second part is site preservation. You are going to build a residential apartments complex in a 1 acre land or 2 acre land. You have to first visit the site, and you can have uh, there are credits for this, uh, not altering the land. That is, at least 10% of the existing topography you should retain. 10% of the existing topography should retain. You will get 1 point. This 10% is the minimum. You can, 100% you can uh, retain the natural topography. Preserve at least 75% of the trees in 1 acre of land. If there are 10 trees, 7.5 or 8 trees you have to preserve. Suppose you are not able to preserve it, you have to plant it or remediate it, and retain at least 50% of the natural rocks. If your land is having natural rocks, don't alter it too much. Minimum 50% you have to keep it, and retain site contour to an extent of 50% of the site, and retain 100% of the water bodies and channels. If your land has some water body, or a pond, or a small lake, you are not able to, you are not supposed to change the landscape. And third part is the passive architecture. Passive architecture, hope you understand what is meant by passive architecture. Just we are not directly investing anything on this, just changing the direction of the house, orientation, putting some skylight, light wells, courtyards, shaded corridors, shading devices. Some external materials we are not putting in, but arranging the things inside, that is called a passive architecture. Corridors, shading devices, shading from the trees, adjacent buildings, pergolas. All these are part of the some examples of the passive architecture. And by that you can you should be able to preserve at least 2% of energy from the annual energy consumption. Total annual energy consumption, if it were not there, it's 2% should be at least be saved by this internal arrangement. That is called a passive architecture. So now please think whether you can do it in your house, or whether you can recommend it to your friend, or whether you can recommend it in a new building, some public building. So if you are able to do that, that is a very small speck on a seashore. Then second part, that is sustainable architecture and design, then site selection and planning. So whatever we do, you have to follow the local building regulations, because a green building constructing in Kerala may not be following the same rule as that in Rajasthan or as that in Tamil Nadu, because we have to follow the local building rules according to its geography, its social contents, its economic situations. And one example is, if the building area is more than 20,000 square meter, the built-up area is more than 20,000 square meter, it should have the environmental clearance certificate, that is EIA certificate. It has to be taken from the MOU. And so for soil erosion control, they have to follow National Building Code of India. It's a 2005, Part 10, Section 1, etc. And basic amenities, all the basic amenities should be available within 1 kilometer from the building entrance. It is basic amenities like ATM. It is not that they are giving a list of basic amenities, some 12, 15 lists there. At least 7 basic amenities should be available. That is their grading criteria. ATM, hospital, school, pharmacy, post office, like that. And it should have proximity to public transport, that is some access to bus or access to taxi or access to auto, should public transport by within 800 meters. And shuttle service should be available at least for 25% of the occupants. And low emitting vehicles should be there to cater at least 5% of the occupants. And natural topography or vegetation should be remaining there 15%. These values, what I am telling now, is not for remembering now, but these are the ways, just to tell, these are the ways how they grade the building. And at that time, we have to think what I can do to reduce my percentage of resource use, like that. Okay. Then when you select a site for building, you can have heat island is a very well heard phenomenon. So the capture of heat during the daytime and release in the nighttime. So for that, you have to use such type of materials, as well as the orientation of the building should be like that, to reduce the negative impact on microclimate. Site selection. So building positioning and building orientation and site selection should have some impact on microclimate. You know what is microclimate? So climate within a small area. So we have to use hardscapes with the minimum solar reflectance index, solar reflective index minimum ആയിട്ടുള്ള materials വേണം use ചെയ്യാൻ. And covered parking, grade pavers, grass pavers, etc. can be used. And high reflective materials should be used for minimum 50% of the roof area, and vegetation for the 50%. So don't bother about the values now, what I am repeatedly telling percentage. Don't bother about that. But these are the components we have to concentrate. Then outside light pollution reduction. Uh, Usually, we are doing this to protect the nocturnal environment. Usually, we put on light in the night time, right? So at that time, the light should not be wasted, and also it should not disturb the nocturnal environment. Just like night animals or more flies which are active in night, don't disturb them. So you have to select your lighting like that. And also, your building should be of universal design, that is for differently abled and senior citizens. So we have, because if you think like that, everybody has enough role in that one. Because personally telling, my sister is a wheelchair patient. She's not able to move here and there in Kerala, because Kerala, most of the buildings and places and tourist spots are not wheelchair friendly, or not differently able friendly. But you can think, how can a person to be able to access the building you are planning to build, like that. So a building should have universal design, that is for differently able people, and the senior citizens should have access. And basic facilities for construction workers and green building guidelines should be demonstrated to. It should be not pasted, or it should be published everywhere, so that the occupants or the users should be motivated by such practices. Because, for example, your waste is your responsibility. But reading that, we should have some spark in our mind, right? So like that, you have to showcase it. Next is a very important part, water conservation. Water conservation is having a good mark in the green certification process. The most important one is rainwater harvesting. So that is a mandatory thing in the certification category feature. Rainwater harvesting. So why we are doing rainwater harvesting? To enhance the groundwater table and to reduce the municipal water demand. You should not depend too much on municipal water. That is why we are doing rainwater harvesting. And water efficient plumbing fixtures is very important, because in our washrooms, we are using European closets, and it's water closets. So it's a flush tanks. So for every urinal, we should have some what it is called specifically measured flushing system. If it is there, you can conserve water a lot. So there may be technologies like that, and you can do more research on that one, how to conserve water using water efficient plumbing features. Like a passenger car unit, we have a mark like this. This much plumbing fixture should be used for urinal, this much for wash basin, this much for nanny tap or bathing tap, like that. And landscape design, that is our landscape should, even if it is a 5-cent land or a 50-cent land or a 5-acre land, we can design it according to the minimum water consumption. Because if you landscape it like that, every house have a a small courtyard or some plants like that. And if it is a sloping, we can capture water where it falls and use it for retain it in the soil for the maximum time. Like that, we have to do that landscape design. And very important is management of irrigation system. You know that if you take the total per capita demand of water, not domestic, but total public demand, uh, a very good fraction of the water is used for agriculture or irrigation because it is get evaporated. So if you manage that irrigation system very properly, you can reduce the high demand of water for irrigation, high demand for irrigation. So management of irrigation system. So because like a lot of examples are the drip irrigation, sprinkler irrigation, or uh, sense the dryness of the soil and put water accordingly. That is some sensor systems are there. So we can design that according to our topography or type of land. And waste treatment and reuse is you have to handle 100% of your wastewater. Whatever wastewater generated by you, you have to handle it. I'm not saying it should be used, but handle it, and minimum 25% should be reused. Minimum. If 100% is reused, that is better. That is the best thing. Then water metering should be there. Why we are putting metering? Suppose water authority water or panchayat water, if you're taking to know the amount that we are consumed, we are putting meter. So that is the common thing. But if you put meter for different things, not for our house, but if you put it in an industry or a factory, how much water is used for coolant, cooling, how much is used for some other washing, how much is used for some other cleaning, like that. If you can efficiently manage the water use and improve the performance of the building. So water metering is very important. Now comes to the most important one, that is energy efficiency. So there are two mandatory requirements for energy efficiency. One is ozone depleting substances and minimum energy efficiency. We know that we are now crying for the ozone hole that we are uh, reading every day in newspaper and even feeling every day in your day-to-day life. Ozone depletion, ozone hole, and UV radiations are coming down to the lower layers of the earth. And ozone you have to encourage people to use the eco-friendly refrigerants and halogens to reduce the impact on ozone layer. And minimum energy efficiency means for that you have to optimize the energy consumption. For that you have to use the code. You have to follow the code ASHRAE. ASHRAE, American Society for Heating, uh, Refrigeration and Air Conditioning Engineers. That is called ASHRAE. ASHRAE is the standard for minimum energy efficiency. So for that, you have to calculate the embodied energy, using energy as well as the embodied energy. Okay. And for building envelope, you know what is building envelope? Hope you know. So all the physical outside parts of a building, that is wall, roof, windows, etc., are the building envelope. So you have to meet the baseline criteria like solar heat gain coefficient. Solar heat gain, that is certain, some glasses will receive more heat into the building and some type of bricks will not take that much heat into the building. Some mud blocks will not take that much heat into the building. So accordingly, according to the SHGC, you have to select the material And U value is the uh, uh, value that it is opposite to the it is reflectance, it is opposite to the resistance. U value, reflective. And lighting means, lighting also you have to be very careful, because lighting power density should be reduced at least by 10% as per Energy Conservation Building Code. Energy Conservation Building Code is, so for the value prescribed in that one, it has a base value. So at least our house should use energy for the lighting at least 10% below that. If your sit out has some false ceiling and 20 number of lights, the LPD value will be very high. You should not use that. You should not follow that. The LPD should be as low as possible. For air conditioning system, Babu sir has also mentioned about that one. Air conditioning system, we have to use minimum 3-star. A coefficient of performance should be equal to 3.1. Heating system, minimum 2.5 performance should be there. Fans, 3-star fans, pumps, 3-star. 4-star and 5-star will be better, but minimum 3-star will be there. And eco-friendly refrigerants should be used. Enhanced energy efficiency should be there. And we should make on-site renewable energy. And you have seen Kerala CL Cochin International Airport, what is its speciality? 100% solar powered. So they are making 100% of their energy need from the solar. Okay, similarly, their on-site and off-site renewable energy you have to produce. You have to produce, and at least 50% should be, if you are investing for the 50%, you will be credited. Then similar to water metering, energy metering also should be there. Then comes the building materials and resources. What type of materials you are using for the building? So for the materials, even if you are using materials and you are producing materials, what materials you are producing? Waste materials, right? So in the initial process, initial stage itself, you have to segregate the waste. Segregate the waste, whether it is during construction or post-construction or occupancy phase, you have to segregate the waste. Whether it is degradable, not degradable, burnable, non burnable, like that. And if it is a high-rise apartment system or office, there should be some centralized facility for the segregation of waste. And also, you have to use sustainable building materials. What sort of sustainability you can apply in a building? What sort of sustainability? You can reuse the building materials. You can reuse the structural parts. You can use a column. You can use a beam. You can use many other structural parts of the building and non-structural parts of the building. I'm leaving the percentage now because too much values. I'm already making you bored, but even if I tell percentage wise, it will be more boring. So you can reuse the structural part, reuse the non-structural part, reuse the salvaged materials like furniture, door, cabinet, etc. They are not structural part. And materials with the recycled content, that is, you are using different types of plywoods, marine plywood, compacted wood, and Green Pro certified products. If you are using, that will be very good. Then you try to or encourage the use of locally available materials. You are bringing that granite from Rajasthan or from Kadapa to here. Instead of that, you can use laterite or some other materials locally available. That is. Then wood-based materials, that also should be Forest Stewardship Council certified materials. You try to use them. Then organic waste management, handling of waste materials during construction, and also Green Pro certified products and equipments. Then next comes the indoor air quality, that is minimum fresh air ventilation should be there in a building, and that has to, if you have to refer ASHRAE code again. And tobacco smoke also you have to control. If it is not controllable, that is because no smoking area is the Ministry of Health and Family Welfare. As per that, you have to provide no smoking area. And sometimes at some airports and other uh, uh, places, you cannot avoid no smoking area. So in smoking area, so in such cases, it should be 7.6 meter away from the outside intakes, and it should be completely sealed. And building should be equipped with the CO2 monitoring sensors, CO2 sensors. And during daylighting, that is minimum 75% of the regularly occupied area should achieve daylight. Because we are building rooms, bedrooms, with a lot of windows, and then covered with curtains and making it very dark and putting a lot of lights inside the room. So what is the use of that? So in such cases, that condition should be avoided. As far as possible, natural sunlight should enter the building, and that will promote to reduce the artificial lights. Then the occupant should be able to have the outdoor views without that. It makes the people happy and more productive, and no obstruction should be there for at least 8 meters, it is said that. And other facilities should be there for yoga, gym, etc. Then indoor air quality should be tested during construction and after construction. Then this is the last factor, feature of the green building. There we can contribute a lot, because all people are learning from mistakes, right? Or newer and newer products and technologies are coming into the market. IGBC is a team, and they are giving certification based on their knowledge or based on the existing knowledge. And if somebody is there to prove that I am using a newer technology which is not known to IGBC, and if we can prove that it can make this much changes in the environment, this much improve in the environment, that also can be taken as an added point. So here we can optimize the structural design, optimize the water use, and many other, can bring many other innovations in the design. So only thing, you should be able to prove that this is a very new innovation. It is an innovation, and it can have positive impacts on the environmental protection. So this is a very important part of the IGBC rating system. And next time, IGBC added that point also for the upgraded rating systems. So this is a simple figure which can show different components, different ways in which we can we can apply green technologies to make the building green. As time is short, I'm not going to explain. I'll leave this PPT to you. You can read it later. So every window, roof, shade, courtyard, place, everywhere, rainwater harvesting, everywhere you can apply your concept of green building. Case studies, I'm not going to the very details of that one. As the Confederation of Indian Industry, Sorabji Godrej Green Business Center, GBC, was the first platinum rated green LEED rate green as a GBC, as well as LEED platinum rating building in India. And this is Pune Suslon One Earth building, and Rajiv Gandhi International Airport RGIA Hyderabad, Infosys Limited Mysore. These are only few examples. Infinity Benchmark Kolkata, AICTE Knowledge Center Noida, Wipro Technology Solutions Gurgaon. And I'm not sure that whether all others will understand. Next is a case study from, this is a house of my colleague, very near to my home, some 2-3 kilometers away. She is Dr. Archana AP of Faculty of Department of Architecture in Rajiv Gandhi Institute of Technology. Her home is some 1 kilometer from the NH 83. Last year, 2024 IGBC meeting, she got the platinum rated award. Last year, that is in 2024, only one house got the platinum rating in Kerala. So that is her house. And she explained in this article, she explained what are the special features she has adopted in that one. And this is a Malayalam magazine. I think if your participants are not from Kerala, they won't understand it. So she made it, the footprint of the building is only 850 square feet. The total carpet area, or the total building area at the different floors, it was 2,500 square feet, approximately 2,500 square feet, but the footprint is only 850. But she did it in a different levels. The specialties are described in this article. These are the different types of different levels, the leveling and open space in this area. In this area, she does not put any lighting, so it is naturally, and only night lighting is required. So many attractive features are there. I'm sorry that I am not able to communicate all the special features to you in this short time, and also to the non-Keralites, because this PPT is in Malayalam. This article is in Malayalam. Another building is in Pala, that is Pala town. That is a green rated service building. That is a what it is called. It is a building material sale, selling office and building. Ashok, it's a prominent distributor of eco-friendly construction materials. Excellent performance in the water efficiency, energy efficiency, site selection, and adherence to the strict, rigorous building standards. We visited that building, and they explained each and everything from they practiced from the beginning. That is by procuring the land to still the process is going on. Every 3 years they have to upgrade, update, just like accreditation. We have to do that. They have to do that. That also, it's a very nice building. Green interiors and a natural ventilation, etc. And as Suraj introduced me, I now belong to the Tropical Institute of ecological sciences. This is a what it is called. It's a research organization as well as the community development and some projects that we are taking some projects and consultancies. And it is founded in 2004. Let me give a very brief about that TICE. It is an institute in Kerala focused on ecological research and environmental education. And this building also adopts many good features. Actually, yeah, at the time, when it started in 2004, we are not concerned about the green building practices at that, because it started green IGBC itself started in 2001. We are not going for that. We have not gone for that. But now we are looking around us in this building. We are looking around us. What all the green things we have already done and what we can do, like that. We are thinking of that. We used most of the 90% of the office building materials are salvaged or reused materials. When other old buildings are demolished, we hire bought materials from that one. By that materials only it is constructed. Waste is sorted and segregated into biogas and kitchen purposes, and organic fertilizers are used for the native plants, and indoor air quality is used or managed by isolating pollutants, rainwater harvesting, outdoor lights. All these are we are practicing. This is certain glances of our building. We have a rainwater collection pond and earth vermicompost, and all the buildings, and overall it is a circular shaped design. So if you try, we also can get a green building rated certification, but we have to, when it is an extension of a building after construction, it will be very difficult to follow that. So it should be started from the beginning itself. So transforming our home into a green home, we can, no need to go for the certification process, but you just think and as a commitment to the environment, you do apply certain things in your home. You advise your children, advise your students, advise your friends and neighbors to practice this one. It will be added as drop by drop the ocean feels, like that it comes. Thank you so much. With this, let me come to the end. Then let me add one more thing. IGBC is giving training training courses, and if you undergo the course, and they'll conduct exam as accredited professional, and if you pass that exam, we can practice as accredited professional or a consultant in green building. That green building, we can give consultancy services to many other projects, big projects, or not very big or small. We can give services as the consultant. So many of you may know that. Okay, thank you. That's all from my part. Thank you so much for bearing me for this time. Now it is about 9:30, and thank you so much.
Yeah, thank you, ma'am. Yes, now the session is open for query. If you have any questions, you can ask through chat box or via or unmute your mic. Yeah.
Can I intervene for a minute. Can you see a video screen now?
Yeah, yes, ma'am.
Just it is 11 minutes, but I just skipping 1 or 2 minutes, 1 minute from this one. Is it audible when I put on?
Yeah, it is audible.
India ranked third globally outside of the United States with more than 77 million gross square feet of LEED rated green buildings in 2023, according to data released by the World Green Building Council. Now, as we approach the Earth Day on 22nd April, amidst growing concerns for planet Earth, which is combating serious challenges of climate change, we probe India's green building movement to ask, what have we got right so far? What's missing? And how do we accelerate the drive for cleaner, greener, responsible built environment? Now, here's why this conversation is important. It's well documented that the built environment, which includes homes that we live in and buildings that we work in, contributes to 40% of carbon emissions. Now, these CO2 emissions are the biggest contributor to climate change or rising temperatures and global heat waves that we are all experiencing. Break down this 40% and you get 28% of emissions which come from operating a building, which essentially means the energy needed to heat, cool, and power them. The remaining 11 to 12%, which is known as embodied carbon footprint, is counted from the materials used in a building like steel, cement, glass, and how sustainably have these been made, plus the activity of construction of the building itself. The most important statistics to remember and why we're doing this show, that 70% of India's buildings are yet to be built. That's the biggest reason why we must focus on getting it right. We have three important.
I just showed that video that to know that we are now currently in the third position in the to achieve the green building